learn from the veterans very quickly because you need it for the next course. I'm like, okay, well, I'll go with that. But I told you this. I ask every professional that I ever encounter. I had a financial advisor come to the school to talk to the students. This year, different one from previous years. I asked him, I'm like, use calculus ever? No. Use statistics. Like, oh, you mean like finding averages and stuff? It's like, yeah, I do that. I'm like, no. You ever do a hypothesis test? Like, what the hell is that? He's like, we do a lot with spreadsheets and make graphs. I'm like, oh, it's like the first week, man. So, you know, I don't know. I don't know why I have this profession, but I'm taking it. I'm keeping it as long as they'll let me have it. So, A dot B multiplied by C. So these are again properties. So just again, these are numerical cases that could be dumped into the case of a proof. All right. So A dot B in the order that we see it. Let's see what happens. Easy enough, right? Actually, I just jump to it because sometimes showing the work makes it less clear. Because we're going to take a sum anyway, right? So 4 negative, so negative 8. All right, so we're taking the corresponding components, multiplying them, and then adding the results. So 1 times 0 is 0, not 1, fun fact of the day. 2 times 2 is 4. Negative 3 times 4 is negative 12. 4 minus 12 is negative 8. So that's the dot component. Multiply that by the vector C. All right, we got into all the theoretical components related to the dot product last time, and it's one of those things where I really like understanding where it comes from, why it's useful, where all the formulas originate from. But in reality, when push comes to shove, you just multiply the components and add them up, right? So the fact that this is the result that you would get if you took the component of A acting in the direction of B and then multiplied those two vectors together, those two components together, you get that number. That's great news. But in reality, we just need to fulfill the operation at this point. So more on the theoretical stuff down the line. A, 1, 2, negative 3. Dotted against twice C. 10, negative 2, 10. So 10, negative 4, negative 30. Barring any catastrophic errors. Then the magnitude of B squared, which is the nicest question on this whole thing, you really can't get it wrong because knowing the magnitude formula is not too crazy. So worst case scenario, you actually compute the magnitude and square it. But the better scenario would be if you know that the magnitude squared is equal to the vector dotted against itself. That would be even nicelier. So 0 plus 4. I mean, you're going to end up with the same operations anyway, so. 16. Oh, did I not add them? Oh, crikey. Good catch. Crikey. as private would say. Negative 24.